The broadcasting of weather came to life when the first weather satellite launched in the 1960s, and the Weather Channel went on the air for the first time in 1982. Meteorologists predict the weather, create weather models and graphics, and warn the public about upcoming severe weather. They also use special equipment to gather weather information and then use it to broadcast it out live to the public. Advances in technology and television have impacted the broadcasting meteorology industry over the years and only keeps improving. On October 1, 1890, the Weather Service was first identified as a civilian agency when President Benjamin Harrison passed an act transferring the meteorological responsibilities of the Signal Service to the newly created United States Weather Bureau. In 1910, the Weather Bureau started issuing weekly forecasts for just agricultural planning. In the early days of broadcasting meteorology, the weather was predicted and studied for military purposes such as D-Day.
They started broadcasting weather reports for the military because it's obviously critical when you're running missions to know the weather, especially in the tropics. And if there's a hurricane coming, you need to let the naval forces know. So I think it all got its start back then. And then I think somebody realized this is very useful for the general public. So once that happened, it just opened up a whole new world of forecasting. And I think it started as a way to let military people know if there was any storms coming that could affect their progress.
In the days before D-Day, Allied meteorologists delivered the weather forecast for the days leading up to D-Day. If the weather was predicted wrong, the Allies may have lost tens of thousands of men, and the United States would have lost World War II. Wet weather could hold down the army, and thick cloud cover could obscure the necessary air support for the soldiers. Based on weather reports, June 4, 1944 was chosen at first for the invasion, but then the commander and meteorologist believed bad weather was only hours away, which resulted in the attack being postponed 24 hours. As rain and high winds covered Normandy on the night of June 4, 1944, they wanted to postpone the invasion even longer. So in spite of pelting rain and howling winds, the set day for D-Day was changed to June 6, 1944. Unfortunately, thick cloud cover resulted in bombs and paratroopers landing miles off target, and rough seas caused landing craft to capsize and to land off mark. By noon, the weather had cleared and the forecast has been validated, and North America made a great comeback and defeated Germany. On May 2, 1982, the Weather Channel launched its first weather forecast. The Weather Channel broadcasts weather-related news, documentaries, and entertainment programming related to the weather, and then broadcasts the local weather live on every eighth of the hour, informing viewers on their local conditions, including temperatures, sunset and sunrise time, the weather forecast ranging from 5 to 7 days ahead, and more. WeatherScan, launched in 1999, is a digital cable and satellite channel that maintains a format consisting of local weather forecasts in a continuous loop with no commercial interruptions. The WeatherScan provides current conditions and weather forecasts for your local and your surrounding areas at all times, with weather information such as temperature and wind speeds being shown on the top right corner of the screen. The reason you can see weather maps and what the future of the weather holds is because of the weather satellites circling around our atmosphere. The weather satellites capture pictures of cloud formations and sends the images back to Earth. Meteorologists then study the images and predict the weather for the next couple of days based off of these images.
People don't understand, it's been said that if all weather satellites could see were hurricanes, that they'd still be worth 10 times what we paid for them. But they do so much more than that. And they not only measure temperatures of the ground, the land, the ocean, the cloud tops. And if we know what the temperature of a cloud top is in a thunderstorm, then we can have a very close guess to how high into the atmosphere that storm is. And that gives us a good idea of the intensity, the risk of hail, the risk of severe weather. So not only do they show us where the clouds are and where fronts are, but they can even measure the winds around a hurricane. And satellite meteorology is a vital factor in what we can do today.
The world's first weather satellite, known as TIROS-1, was launched on April 1, 1960. TIROS-1 was the first satellite to help meteorologists view the future, making it possible to see potential disasters and giving civilians time to prepare for them. TIROS was NASA's first experimental step to see if a satellite could study the Earth. TIROS was only capable of cloud systems. City lights, fires, pollution, auroras, sand and dust storms, snow and ice, and boundaries of ocean currents and other environmental information are now collected through several environmental satellites today.
The satellite is it's floating up in space, so it's looking down to pick up cloud data. Radars, which are constantly spinning, trying to pick up moving objects in the atmosphere like rain or snow or hail or sleet. That's very helpful to us. So when we see clouds and then precipitation movement, we certainly know if it's headed our way or not, and then we can use some of the models to extrapolate that and figure out when it's going to arrive.
The first picture that was received from Tyros was a fuzzy image of thick clouds covering the United States. Meteorologists then combined Tyros images into the first global view of Earth's weather, picking up a line of clouds over the Pacific Ocean moving towards the United States. Tyros only functioned for 78 days. Weather satellites have helped save lives during disasters, making these spacecrafts a powerful toolkit to monitor our planet. Broadcasting is the distribution of audio and video content to an audience through mass communications. The field of broadcasting includes a wide range of practices, from public radio, community radio, and commercial radio, public television, and commercial television. Broadcasting in general focuses on getting one message out to the public and then leaves it up to the general audience to do what they wish with that message. When the weather is broadcasted over the television, you can see the visuals and models and personally see what kind of weather you should be expecting in the next 5 to 7 days. Meteorologists who broadcast the weather on television must have a peppy and enthusiastic personality. They must wear professional clothing and use appropriate hand and body gestures when live on television. When the weather is broadcasted over the radio, the meteorologists do not have to have much of a personality, they just have to be good public speakers.
On the radio, again, you don't have to have as much of a personality. You're kind of just reading the forecast. People just want to know about it, but on television, they want a little something more. If people are, in my case, getting up every morning and having a cup of coffee with me, they want to know the weather, but they also might want a joke or two or a humorous way to deliver that forecast. They want to spend some time with you rather than just hearing you. So I think you've got to have that persona. You've got to have a friendly personality that's reliable. It makes you one of the family, kind of in that regard.
The radio's audience does not get as much information about the weather as you would get from watching a broadcast on a television. The radio's meteorologists give you the weather that is predicted for that day, night, and the next day without any visuals or models. Weather broadcasts used to be pre-recorded and then broadcasted instead of being broadcasted live out to the public.
The TV part I've been doing since 1980, 35 years, so I can do that in my sleep. But the forecasting is always the same. It's always difficult, it's always a challenge, and it's a fun challenge. I'm the first person that knows when it's going to snow. But yeah, the forecast is always a challenge every day, and that is the most difficult thing I do. That in severe weather, it's very intense. We don't have a lot of it, but I've worked in markets where I've been on the air for 7.5 hours with tornado warnings, and that's very, very intense, and your mind is drained at the end of a day like that.
When it comes to broadcasting the weather live over the television and radio, the meteorologist must share the same skills such as passion, communication, meteorology, and they must understand the forecast models and how they work. Broadcast meteorology combines passion in weather, communications, technology use, and reporting. This includes answering emails, phone calls, social media postings, and promotional visits. Being able to provide current and updated information with your audience is important with communication. Meteorology skills and communication skills are important, and you must have the degrees in meteorology, journalism, and communication. Communication skills are important when you want to be a broadcasting meteorologist, so you would know how to communicate with the viewers in case of severe weather. Many of these skills take significant time to develop and are a product of personally matched with experience. You are also going to need to understand several different kinds of weather models. Forecast models are what helps meteorologists predict the ocean current, the wind speeds, and the future temperatures. When a broadcaster is live on television or on the radio, they always make it a priority to give the audience and the viewers what they want, and then the broadcaster puts all the information into one show. The basic information that is wanted is what temperature pattern to expect and if there's any chance of precipitation. When there is severe weather in the area or heading towards the viewer's location, the viewers want to know where exactly the weather is going and what to do. Severe weather has an immediate influence on the viewers' lives. Viewers want a weather broadcaster that will show where the severe weather is, explain how much of a threat it is, and explain what they should do. The broadcasters then explain throughout the forecast since the information is crucial to the viewers. If the weather broadcast is made too technical, this risks turning out a significant portion of the audience. and if the weather broadcast is too watered down, this risks looking unprofessional. One goal of a broadcasting meteorologist is to both teach something about the weather to those without much weather knowledge, while at the same time being very informative to those with weather knowledge.
So you've got to be able to take that complicated science knowledge, and then the second thing is you've got to make it relatable to the viewer that's watching. So we can talk all we want about what makes up the atmosphere and all the complicated stuff that we learn in college, but I think the biggest thing is people want to know, do I have to take the umbrella today? Do I need a jacket? So you've got to make the science, the complicated part of it, very relatable to viewers, and you've got to have a good personality so that people want to invite you into their homes every day. So there's a lot going on. It's not just showing up and getting in front of the camera. It's understanding the science, making it relatable to the viewer, and having a good personality so that they want to spend some time with you each day.
When broadcasting meteorologists come into work, they study several different weather models and graphics, and study the weather patterns so they can put together an accurate forecast for that day and the days coming up. On a typical day, they report on weather conditions such as blizzards, tornadoes, hurricane, earthquakes, floods, forest fires, and many more. They get all of their weather information, knowledge, and forecasts from looking over current weather charts, satellite and radar data, and National Weather Service products. But in today's improved technology, meteorologists also use internet and viewers' reports to put together an even more accurate weather forecast.
One of the tools that we use are computer models. When we're actually making a forecast, we have to look at a lot of the guidance, and we learn how to go through this and use it in college. But I always say we have a great job because we actually get to tell the future. So a lot of the models and a lot of the equations that govern the atmosphere that we have to learn piece by piece throughout our college days, they're put into a computer, the computer spits it out into a model, and then we get to use that to actually make a forecast.
Meteorologists look at many models such as climate models and ocean surface temperature models. Climate models are a mathematical representation of the climate. In order to do this, the models divide the Earth, ocean, and atmosphere into one grid. The meteorologist must make a large number of assumptions and perform a large number of calculations. The values of the predicted variables such as the surface pressure, wind, temperature, and humidity, and rainfall are calculated on each grid over a point of time to predict their future values. Climate models have been developed from weather forecast models, but due to all the calculations involved, climate models now use a bigger grid and spacing and longer time steps so that you can be ran farther ahead in time for the given amount of computer time. A number of factors cause sea surface temperatures to vary around the world. For example, the sun's rays roll on the ocean surface. Heat energy flows between the ocean and the overlying atmosphere, moving from warmer to colder. Heat is then removed from the ocean when the water evaporates from the ocean's surface. When looking at ocean surface temperature maps, meteorologists can tell the temperatures from color of the model. Red areas are the warmest. Orange and yellow shades also show warm surfaces but growing progressively cooler. Green shows the intermediate value, while light blue and dark blue shades show colder ocean temperatures. Broadcasting meteorologists use much more technology and instruments than just weather models and graphics. When a meteorologist is on the air, they are standing in front of a green screen. If you are on the other side of the television, you can see weather graphics and maps that are color keyed into the green screen. Chroma keying, also known as color keying, is the process of singling out a particular color in an electronic image and then using special effects in different color softwares to make that color transparent. This allows another image to be keyed into the green screen, allowing it to show through. Computers with special advanced editing software then make that shade of green effectively disappear, allowing another image, such as an animated weather graphic and model, to show through instead of seeing the green screen. These weather models show temperature, air pressure, wind speed, and precipitation values.
We've already seen them move away from the green screen. We've seen them move to kind of these big TVs, these smart boards, if you will, and so there's more interaction with it. I think the technology is going to keep evolving. We've actually seen some prototypes now where there's a 3D environment. So if it's going to rain, the meteorologist is actually standing in, three-dimensional rain falling around them to depict what is going to actually happen that day. So we've seen the technology advance, and from broadcast television to now we're on Facebook, we're on Twitter, we're issuing forecasts on the internet. So I think everybody's always going to need to know what the weather is going to be. I think how we get that information or how we even project that information may change, whether it's 3D graphics, whether it's on your smartphone and you pull up a meteorologist talking to you about what's going to happen. I think everything is constantly evolving.
Broadcasting meteorology has changed dramatically throughout the years, from only doing radio broadcasts to broadcasting live nationally on television. Now it is even more accurate due to the advanced technology that only keeps improving, from weather models to weather satellites. Meteorologists expect much more improvements to the broadcast and to the equipment used for the broadcast over the next several years.